Okay, so today we're going to talk about sound waves. Now, to review so far, we've talked about um, what waves are, and what's transferred. What we consider a wave is when energy is transferred. We talk about water or ocean waves. It's not, the wave is just energy moving through there. Water is just the medium through which it moves. And we talked about mechanical waves. Those are ones that require a medium, either a solid, liquid, or gas to move through. And those are broken down into two types: with transverse and that's when the particles move perpendicular to the direction of the wave. An example would be like an ocean wave, and that would be a transverse wave. All right, and then we could label the different parts. At the top we have the crest, the bottom we have the trough. The distance between two crests or two troughs is wavelength. And then the higher the wave from the rest position, the height there would be the amplitude. So the higher the amplitude, the more energy a wave has. The shorter the wavelength, the more energy it has. And the higher the frequency. And we said frequency is the amount of waves that move through a point in a certain amount of time. And frequency is measured in hertz. Now another type of wave, the second type of transverse wave is a longitudinal wave. And those are when the particles move parallel to the direction of the wave, they move in the same direction. And longitudinal waves, some examples would be like a slinky and sound waves. Now, the next type of wave is electromagnetic. And those are types of waves that are on the electromagnetic spectrum. And they do not require a medium. They can move through empty space, like X-rays, visible light, ultraviolet radiation from the sun, microwaves, radio waves. Now, waves are a big topic in physics because a lot of our new technology revolves around wave technology. You think about cell phones and Bluetooth and anything like that. Of course, X-rays, you can tell if you have a broken bone or something. And ultraviolet radiation from the sun, microwaves that we use to cook our food. Now, moving on to sound waves. We want to know what is sound, how do sound waves travel, how do physical properties of a medium affect the speed of sound waves, what properties of waves affect what we hear, and what is the Doppler effect. Now, sound is vibrations that travel through the air or other media. When these vibrations reach the air near your ears, you hear the sound. Think about one of the following rule. If a tree falls in a forest and no one is there to hear it, does the falling tree make a sound? Must you hear a vibration for it to be sound? Is the energy produced by vibration a sound if no one hears it? So develop your own definition for sound. The sound waves carry energy through a medium, solid, liquid, or gas, without the particles of the medium traveling along. So as the wave, the energy moves through, it's moving parallel to the wave's direction. And the sound travels as a longitudinal wave. The medium is just something that it travels through. How sounds are made. Longitudinal waves are generated when a source of energy forces the matter in a medium to vibrate. We already said that what causes waves are vibrations. Think about seismic waves, are caused by an earthquake, some vibration. This back and forth motion pushes air particles together, generating a compression, or moves the particles apart, generating a rarefaction. So a tuning fork will make a sound wave, and it's got compression and rarefaction, what those mean in the diagram. Why can't sound travel through space? Well, sound waves must have a medium to travel through. They can't travel through empty space. Gas, air is the most common medium for sound. In outer space, there are no molecules to compress or rarefy, so sound does not travel through outer space. Sound travels in waves like light or heat does, but unlike those waves, sound travels by making molecules vibrate. In other words, for sound travel, there has to be something with molecules for it to travel through. Think about space. Can sound travel through space? Explain your reasoning. So answer that question as you go through these notes. What unit measures the speed of sound? Now, the speed of sound, of course, it's in meters per second, but it depends on the physical properties of the medium it travels through. Elasticity, density, and temperature can all affect the speed of sound. At room temperature, sound travels through air at about 342 meters per second. Of course, it doesn't travel near as fast as light does, but still travels fast. Now, the physical properties of media that sound waves travel through. Elasticity is the ability of a material to bounce back after being disturbed. Solid materials are usually more elastic than liquids or gases. Particles of solid do not move very far, so they bounce back more quickly as the vibration travels through the object, which allows waves to move faster. Now, another physical property of the media is density. It's how much matter there is in a given amount of space. The speed of sound depends on how close together the particles in the substance are in the medium. Why does the sound travel faster in a solid medium? Well, it has to do with the particles are more closer together in a solid, so it's going to move faster. Now, temperature, degree, or intensity of heat present in a substance or object. If you notice that speed increases as the temperature increases. In a given medium, solid, liquid, gas, sound travels more slowly at lower temperatures. And it has to do with their particles, how fast their particles are moving. So some more properties of sound waves is intensity, loudness, frequency, and pitch. Intensity is the amount of energy the wave carries per second through a unit of area. Amplitude increases with increased energy. That's the height of the wave. And that's measured in watts per square meter. Now, loudness describes what you actually hear. Though not the same as loudness, the greater the intensity of the sound wave, the louder it is. It's measured in decibels. And the maximum safe level is 85 decibels. So it says name 2 sounds that are not safe for human ears. And you can see on the chart there, and you can answer that question there. Another property of sound waves, frequency. That's the number of vibrations that occur per second, or the number of wavelengths that move through a given point in 1 second. And if you look, wavelength changes with frequency. If you decrease the wavelength, you increase the frequency. If you increase the wavelength, it decreases the frequency. Now, if I ask the question, which color has the greatest frequency, it would be the one on bottom, the blue one or the purple one there, the violet. red would have the lowest frequency because the wavelengths are spread apart. Now, another property is pitch. It's a description of how high or low the sound seems to a person. High frequency, you have a high pitch. And a low frequency, you have a low pitch. Think about the physical properties of sound waves, including intensity, loudness, frequency, and pitch. Describe how frequency and pitch are related, and describe how intensity and loudness are related. You need to answer those two questions as you're going through this PowerPoint. And one last thing is the Doppler effect. It's the apparent change in frequency as a wave source moves in relation to the listener. You think about when an ambulance comes, sounds moving towards a person, waves are at a higher frequency, so pitch appears to increase. So as the ambulance is moving to you, you notice it's getting louder. The sounds moving away from a person, waves are at a lower frequency, so pitch appears to decrease. And that is the Doppler effect. So you need to answer these questions right here as you go through the notes. And then last, you're going to give your best answer to these 4 check for understanding questions. You can answer those in your notebook.